I am your host, Richard Brown, Director of Marketing. Other speakers with us today, we have Chuck Hansen, CEO, Mike Epp, Executive VP, Matt Campos, VP Product and Development, and David Kinsella, President of Element 82 and PE Pipelines. Before we get started, please mute all microphones. Use the chat box if you have any questions or comments. Type questions into the chat window or email me directly at richbrown@electroscan.com. A link to this presentation will be available at the end of the webinar. Okay, and what's coming up next? We're going to have a few fun questions throughout this presentation that you really don't have to answer, okay? So let's start with this quick true and false question. The LCRI now requires flushing of all water lines after potholing and customer notification. Is that true or false? It is absolutely true. The LCRI now requires flushing of all water lines after potholing and customer notification. Absolutely. Well, let's get on. Let's get on with the agenda. Now we have Chuck Hansen is going to kick off and talk about turning unknowns into knowns. Okay? And why is it so important? We have Mike Epp he would talk about validating existing service line inventories. Matt Campos will talk about moving from prediction to certainty. And Mike Epps will talk about DC Water's benchmark, okay? And we have Dave Kinsella. He would talk about lead replacement strategy. Mike Epp will come back and talk about 5 case studies in lead detection. And I will wrap it up with the Q&As. Okay? So take it away, Chuck.
Hey, thanks, Rich. How's everybody doing? Day after Veterans Day. Thanks for coming. I've been dying to do our first webinar here at Electro Scan. With my 40 years in the pipe inspection business, I thought I would just show all of the different cell phones that I've used or had over the years, just to emphasize the years that we've been at this. I used to show this slide in describing underground infrastructure to politicians because they never really understood where things went, and they always thought that the water mains would be on the left-hand side and the sewer mains on the right. And they didn't really realize that this is what it looks like. And there's actually a guy with a straw hat. And so this picture was in the 1920s. And I've been in New York, and I've been to the same intersection. They've added to it since then. So it's only gotten worse. Here is the spoiler alert about water service lines. It's the same thing. So if you have a state that has required a 2-point inspection, let's say looking at the meter box and a faucet for the hose bib, guess what? That is not going to predict or not going to tell you what the pipe is, especially if the home was built before 1986. It's just not going to happen. And that's based after thousands of electroscan inspections in the field. GIS has also been a little bit difficult to use because most of the water service lines that were created were done in an automatic way. We take the center point of a parcel and stick it to the closest water main. So it's always a straight line. So we really can't use this to dig. What we're having to do with unknowns is not just define the infrastructure that we can see. We have to look at the water service line, both from the main to the meter and the meter to the house. That is critical. And I've just put in borrowing from DC Water, just the great example of all of the different combinations that we can have. In California, we are finding it's all about the home that the year was constructed. That's key. And once we do that inspection, able to have that data go up and immediately be processed in the cloud, to create that final report. And so whether we know if it's lead, whether we know it's a non-lead, having that information delivered directly to the customer before we leave the property. And our goal is very simple. It's very simple with this presentation. It's that we want to help certify test results to the homeowner. Right now, most cities refuse to certify their lead pipe inspections because they actually know that they haven't looked at the underlying pipe. So that's what this webinar is going to be. Hope you have a great time. And Rich, I'm going to kick it back to you.
Man, thank you, Chuck. We have another question. How many days will water systems have to respond to a customer that disagree with their initial pipe inventory? How many days? 5 days? A. B, 10 days? 30 days? Or 60 days? And E, whatever system are not required to follow up once the EPA has accepted their inventory. Which one is it? Absolutely, it is 60 days. It takes 60 days. All right, at this time, Mike, it's all up to you.
Thanks a lot, Rich, and I want to welcome everybody today as well. The purpose of this is to validate our existing service inventories, and the ultimate question is after you get through all the data mining, you get through all of your records research, there's going to be those pool of homes, the unknowns that we simply don't know. We can't make a determination, and obviously the LCR and the LCRI both require a positive determination to be made about them. So the question is now, do we dig or do we not dig? When we're talking about electrical resistance, we're talking about the pool of tools that the EPA called alternative methods, emerging methodologies, and that is AI data modeling, that is, electrical resistance, that's acoustic eddy waves. Unfortunately, as some of you may or may not have known, another major player was coming into the market, and unfortunately they pulled their tool back out because they couldn't get it to work the way they wanted to. And unfortunately, that's left us simply with two options, to dig or to not dig. And this is what we're left with. And as a former contractor of 20 some odd years in the rehabilitation business, I've done my fair share of potholing. And my ears still ring from it, not to mention everything gets vibrated. So we're either left with doing it to traditional excavation methodology or by utilizing SWORDFISH itself. For everybody who has not seen the LCRI, potholing is now considered a disturbance. Potholing and all excavation, hydro excavation, doesn't matter. All methodologies have to be done with flushing. And the reason is this. When you're doing hydro excavation, if you've never seen it done, it is not a pretty thing, particularly when you live up here in upstate New York, where our water lines are 10 foot deep. That's 10 feet of soil we have to go through with a hydro excavation or an excavator, 5,000 PSI water, 5,000 mercury vacuum. Those lines vibrate. They move a lot. And when we're spraying water, we're dropping every rock and everything down and we're hitting the service lines. So as of right now, all of this, any excavation, simply turning off a meter is now considered a disturbance, and we need to make sure we're doing it. And as you can see here, this is from one of our leak detection devices, our Trident, but we actually can track the particles inside of a water line, where they're going. This is reality. And the AI makes sure that when we're seeing it in the leak detection, we're also seeing it in the lines themselves. We've always assumed that what we do is a disturbance, well before the LCRI came out and said everything is. We've always followed the AWWA CA10-17 partial lead line replacement strategy for flushing of service lines. And the rules for the AWWA say you need to have a minimum of 10 minutes of cold water flushing. Well, we've always exceeded that limit for everything in which we do. And as you can see here, it's one thing figuring out what the material happens to be. It's a whole nother thing about utilizing the data. And as Chuck just mentioned, turning an unknown into a known is critical because you have to have that whole 360 degrees. Because what we're doing here in 2024, we're not sure when we're going to get to actually pulling that stuff out of the ground in 2027, 28, 29. We need to be able to have organized, captured data to be able to make sure we do that. And that's one of the things Swordfish provides. What's electrical resistance? Matt's going to talk about this more in depth, but basically for all of us who, graduated, high school in the 80s, we all did this in silent experiment. There's a battery on the blue wire, there's a light bulb on the green yellow wire. And that's what we're doing. We're simply passing electricity through the water, through the pipe wall, in this case, the service line, and then making a determination of what it is. This is the periodic chart of elements, as we've all seen. I only ask you to look at one thing and one thing only. That's the third line, electric resistivity. And the reason I ask you to look at this is because what you see is copper and lead. Copper's 1.7, lead's 21.3. Folks, it doesn't matter if I'm in upstate New York. It doesn't matter if I'm in Baltimore. It doesn't matter if I'm in Florida, California, whatever. A copper pipe looks like a copper pipe. A lead line looks like a lead line, all those places. They're apples and oranges, and this is why electrical resistance works the way it does. As you can see here, this is a trial setup that we did at Miami-Dade, but the most important thing I want you to look at here is the fact that there's multi-materials here. On the right, you see all copper, and the one in the middle is copper to galvanized, then it's copper to lead, and it's all plastic. On the private side, we find changes in material highly often. And because of that, we need to be able to mark that information, not only by the material, but also by its location. As we look at as the data is coming through, this is what the data starts to look like. And I'm going to go into a little more differently, but what you're looking at here is 11 volts of AC power that we emit from the probe, a C battery, and basically all of it comes back. That's copper. When we are looking at a plastic's highly resistant to electricity, so we almost get none of it back. It all depends on which material it happens to be. This is the one we're all hunting for. This is basically, it looks like an EKG at the doctor's office. It's all over the map. The reason it's all over the map is that lead was never extruded. It was a poured and rolled product. So it acts very differently. We always knew why it twisted and turned and why we all used it, because it was easy to use. But what happens when we find those changes? This is what's important. You see a lead line on the left moving to a copper line. But I want you to look at those dots between the two. Each one of those dots is 1/3 of a second of time. That's critical. So as we're changing material, we're capturing that in real time. This is a galvanized to a copper line. You can see the change takes place in roughly over 1 second. That's where the data comes in, is so important. This is a galvanized line to a lead line. These are the things that we can see, and we capture that not only by what material it is, by where it is by exact distance. Now, this one, believe it or not, is a real scan. It's a city that has a huge lead problem. But what you're seeing here is a copper whip out of a meter box to a galvanized line that went roughly about 8 feet, to a lead line for a couple more feet, and then it went galvanized into the house. All of this took place within 14 feet. And that's not unusual. The older the communities we have, you never know when a house was built in 1926, what every owner's done with that property and that water service line for the last 80 years. So, and because no one had to pull a permit, nobody had to understand and report that data to the utilities, all these are unknowns. And here's the ultimate, the wheel of everything that you have. We're trying to find everything. We're trying to find connectors. We're trying to simply find lead lines, soldered lines. We're trying to find lead packs. All of this is the issue that we're having today to deal with. And that's what the major issue that all of you have is that we're finding those changes in materials as they happen. And most importantly, we're telling you right then and there what this house happens to be. So we're taking it from an unknown and we're making it into a known. Now, we are not a silver bullet by any shape, matter, or form. We have a lot of very, very positive things. We're accurately defect all of our pipe materials. There's absolutely no digging or excavation that's needed. We offer services and sales. We're backed by industry veterans, instant reporting of the results. We've been multi-benchmark studied by many state regulators. The manual some of you have seen was actually approved and edited by Pennsylvania. Now, some of the negatives. We can't get into everything. Unfortunately, the plumbing for the last 200 years here in the United States has created some interesting environments. Now, we work around those as best we can, but some things we just simply can't get into. We also require flushing after every test. We do that to protect not only the homeowners, but also everybody from there. Rich, back to you.
Wow, thanks, Mike. That's some great information. All right, we're going to have another question. It's a true or false question. The deadline for resolving all unknown pipe material is 3 years from the date that the LCRI became effective, October 8, 2027. Is this true or false? It is absolutely false. The deadline for resolving all unknown pipe material is the 10-year deadline for lead pipe replacement. All right. Now take it away, Matt. It's all you.
Yeah, thanks everybody. So I'm Matt Campos, the VP of Product Development. I oversee basically how this tool has been brought to market. We've been using electrical resistance testing. Now, this is a technology that's been around since the 80s. It's a proven technology. We've been using it for leak detection since 2011. It's in the M77 Condition Assessment of Water Mains Manual. This is approved technology from the EPA. So it's been independently tested. Ohio, Miami-Dade, and Denver Water. They kind of put us through a obstacle course on a few things. Just want to see, is this snake oil or does this thing really work, before we go out and start deploying it in the field. So the technology is proven, but one thing that we had to do was how do we get this technology into a water main? Now this tool is designed to work from 1/2 inch to 3 inch and go around multiple 90-degree bends. We had to obviously go against pressure. If you're going from the meter to the main, we have to go against pressure, and we have to keep the thing sanitary. So the way we did that, it was use a chlorination chamber. So the chlorination chamber does 3 things. It allows us to push into the pipe up to 150 PSI. It has a section on there that we fill with chlorine, so it has a chlorine bath. The last thing the cable touches is a chlorine bath as it goes into the pipe. And it has a footage encoder, so we know how far down the pipe we've gone. After we figured out basically how to safely get in the pipe, we need to know how do we navigate the pipe. So there's 2 different entry methods we do, either a basement entry or a curb stop entry. The reason why it's these 2 locations is that's where the meter is located. So what we're going to do is pull the meter out and install our chlorination chamber and launch tube either in the basement or the curb box. Now, as you guys know, plumbing isn't always just a straight pipe, kind of like we saw from Chuck's slide where it picks a point straight to the center of the property. Well, it can kind of worm around a little bit, especially you have copper, any of the soft materials that were in a roll, copper, lead, any of the poly, it doesn't necessarily go straight. So one cool feature we have on the SWORDFISH is we have a tracing ability. So you could plug your tracer, whether you use one of those rigid tracer wands, something like that, and trace the cable and see if you have spools of copper just outside the property. So now that we figured out how to get into the pipe safely, we go against pressure, we keep it clean. How do we navigate 90-degree bends? Well, as you see here, we have like 360 degrees of total offset just to get started. And that's just to get started pushing. So we had to design a cable and probe that was able to go through multiple fixtures and 90-degree angle valves. The risers, obviously, you see the big three here. So we have AY McDonald, Ford, Mueller, and that's just to name a couple of them. But each one of these companies makes multiple different styles and lengths and diameters and valve designs that all have different internal geometries. That is just something that we had to overcome. We see that in basements too. Now, basements could be a little like the Wild West. Obviously, and I'm sure a handful of people on this call have their meters in basements and they see this time to time. But since the meter's in the basement, someone's not there monitoring the plumbing as well as if it was in a curb box. No one could go look at the meter anytime they want. They can't just go exercise the valve anytime they want. They have to make appointments with the homeowner. So therefore, what we're seeing in basements is the plumbing is a little more degraded, a little older. Some of the valves and stuff are original and they haven't been messed with or exercised since they were installed back in the 40s. So that was another hurdle to overcome. If we have to disassemble this, how do we do it? But once we get the meter out, we have different probe designs. And this is something that when we first started, like, hey, we got a probe design, it pushes down a pipe good, it goes around 90-degree bend, great, we're off to the races. Well, that wasn't really the case. When we launched this product in 2021, the first probe design wasn't the end-all be-all. We have multiple different probe designs, and it's been over an evolution where the original probe designs are not used anymore. We have, just created new ones that solve those issues and work much better. Another problem, and you guys might have some valves like this, is a valve that has a chamber, basically a recess. It's a 90-degree valve, but if you go straight in with a probe, like you see in this picture, it wouldn't navigate the 90-degree bend on its own. It'd get caught in that rear chamber. So another problem we had to overcome is using the SWORDFISH redirect tube. So what that does is redirects the probe around that 90-degree bend. So you can see in the picture there, it has like a little scoop. So there's a handful of problems that we had to overcome when we first launched this thing, and the ability to safely install our launch tube and keep everything clean and go against pressure, and then navigate these multiple 90-degree bends and push it up the pipe so that we can get the data. Of course, there's some advantages and disadvantages of this. This has been tested on hundreds of meter setups, different configurations, different valve sizes, all that. We've pretty much seen it all. And some of you guys might have seen our big demo tour we did, and so we've seen a lot of different designs. I'm not saying we've seen it all, but we've seen a lot. Of course, we could go against pressure up to 150 psi with the chlorination chamber. We don't need to dig anything, and this is a proven technology. The technologies never came into question. It's just how do you get it in? And of course, some of the disadvantages. This has been talked about a little bit already, but we can't get past bad joints or heavy debris in the pipe. You guys have seen, galvanized line that was 3/4 inch, but now it's maybe a 1/4 inch diameter inside. Well, that's just something that we just can't get through. Hopefully, once we get into that, we could see it's a galvanized line and we could just mark it off as galvanized. But sometimes we've seen copper pipes that are rolled out and they were just kinked really bad. Well, we can't push through it; it's too kinked. So some of those things, it's just nature of the beast when we're getting some of this old plumbing. Then some of the old meter settings that are just too fragile to remove. Sometimes we'll walk up, we'll get ready to do an inspection, and the meter setting, it's got an old galvanized line coming up to the valve, and it's already seeping a little bit. It's like, if you start cranking on that to turn it off or remove the meter, that you're going to end up having a leak. So that's just some things that we run into. And the way we overcome that when we do projects is we always have a local plumber that the water utility trusts and knows. They're just on call. If we see one of these, we don't walk away from it. We call them up and say, hey, we got another one. They come and they'll cut that valve, and replace the old valve that may be leaking or a problem, put a newer modern quarter turn ball valve on there, and that allows us to have an entry point that is safe and we're not going to have any leaks or problems. But yeah, other than that, Rich, back to you.
Wow, Matt, that's some great information. Thank you. Thank you very much. We have another question. All right. A major change in the LCRI was the addition of what? to be replaced in a 10-year period. A major change in the LCR was the addition of what to be replaced in a 10-year period? A, lead pipes located inside the home. B, lead solder joints in asbestos cement pipe. C, lead connectors. D, galvanized pipe regardless of upstream. Or E, all of the above. Which one was it? It was C, the lead connectors. Okay. Well, take it away, Mike.
Thank you very much. I'm going to talk about a benchmark study, not about the results, but about the why it was actually put into place. And the screens I'm going to show you were publicly released, and this was specifically done by DC Water to imagine a city without lead. DC is well ahead of most communities here in the United States. And what they did is they're trying to find a better mousetrap. And, you know, obviously this was presented to the Environmental Quality and Operations Committee on October 17th. And the biggest reason that this was done is because that DC Water currently uses test pits. And the test pits is that, as we've talked about excavation, it's highly disruptive. It's a slow process. It's very expensive. And this is important because they will have, DC was looking to find something that doesn't disrupt the ratepayers until they have to. How do we save money? And how do we make it better for everyone? And letting the contractors do what they do best. Replace the lines. When we're having contractors out there finding things, it costs time. It's ineffective in what they do. So when we're looking for this, every community in the United States, if you don't have a chart that looks exactly like this, you should really get one. And the reason that DC made a decision to go into looking for a better mousetrap, as I said, is based off of the fact of their EPA edition of unknowns. They have 81,078 unknowns they have right now. Well, that's not a lot. Not when we have communities that we're dealing with in the 100,000, 200,000, 300,000 unknown side. The issue is this. DC has made a decision and set up their own timelines of what they're trying to get accomplished. And their contractors, in the best that they can do, can only get through roughly about 6,000 houses or replacements a year. Because of that, they need to somehow make that number smaller. The contractors can only do so much. But how do we take that population of 81,000 and make it into a smaller number that can get done in the time in which the goals in which DC Water wants to do? That's why they've looked at utilizing us and another methodology. Because the nice thing is about what we do, we're fast. We are cheaper. We are far less disruptive. And most importantly, we answer the question of now. We can then tell the contractors to go down which street to go to which house. Traditional method they have, EDT, SMIT was another company that was out there, and SWORDFISH was the third company. What were we looking at? CDM Smith was the engineer. They were the ones who were reviewing what we were doing, monitoring our SOPs. They timed us and documented everything we did, from removing the meter, disinfecting the probes, testing both the public and the private side. And the unique thing about this is that even though we thought we understood what DC Water's network looked like, reality was totally different. In fact, DC was a bit surprised about the configurations of the meters, the yokes, the piping that we found, because they didn't have any record of it. And that's not unusual. There are a lot of people out there who simply, we think we know what we've got, but until you literally go to 50 houses, 100 houses, do you only start to realize really what you've got and that's out there. And that's not unusual. And that's part of, as Matt said, things we've had to deal with and what we went through. We then flushed for 30 minutes. Yes, that's in excess of our SOP, but that's what DC Water's SOP for this project was. And then we reported the results, provide filters and flushing and internal instructions to every homeowner we went to, whether there was a lead line discovered or not, which there were not. But the most important thing was the time to test, all through steps 1 through 5, less than 1 hour. And that was important because when they wanted to look at the results, they want to understand it. Some of their preliminary observations, and I'm not going to go through them all, as they were reported to DC. Lastly, we want to thank DC Water for the opportunity that we had, and we want to make sure that, you know, other utilities can take advantage of what we do. And by all means, you know, again, I wish to thank DC Water for their time and for the time we spent down there.
Wow, thanks, Mike. Truly appreciate that. We have another question. It's a true or false. Validation of the service line inventory does not include non-lead pipes. Is that true or false? That is absolutely false. The preliminary LCRI was modified and now requires all non-lead pipes prior to 1986 to be validated. And at this time, we have David. Go ahead, Dave. Dave, you're on mute.
That's not a good start. Thanks, Rich. So I'm part of Crown Electrokinetics. We're a public company that offers a 360-degree solution to the current lead problem. We're fully vested in this industry, and we're providing a lead identification and a replacement solution. So Element 82 is the identification arm of our business. You can see that trenchless has become the primary method of pipeline construction. So we really needed to find a trenchless solution for identification. So about 12 months ago, I set out to find an alternative to vacuum excavation. We wanted a solution that didn't require digging up people's gardens, local footpaths and roadways. So luckily we found Electro Scan, which is a non-invasive method for identification. There is no digging required. So over the past year or so, I've worked with Electro Scan on numerous projects across the US. Their SWORDFISH technology has allowed us to complete a large number of identifications in a short period of time with minimal disruption to the homeowner. This has really complemented our existing business, PE Pipelines, which is the lead replacement arm of the business. And we've 4 different methods for lead replacement. So for all these methods, we would firstly dig down on the water main and disconnect the service line. And we would also disconnect the service line in the homeowner's basement. So up first is directional drilling. In this case, the directional drilling, we drill a new service line from the water main to the basement. We connect our new poly or copper line and pull it back through the line from the basement to the water main. In this case, we have a pit at the water main, at the water meter, and at the basement wall. The new service line is connected at each location. So next up is the pull-through method, which Chuck will move on to soon. This is always the preferred method of construction, as it's simple, it's fast, but it only works in about 20% of cases. Again, what we do is we disconnect the line at the water main and in the basement. And this time we connect the lead line to the bucket of the excavator, and the new poly line is connected to the lead pipe in the basement. As the excavator pulls the lead line through, it also pulls the poly line into position. Once in position, the connections are done. The reason this method may not work is because all lines tend to break because they become brittle. There may be joints in the ground which become stuck as we try to pull through the lead line. There may also be coiled pipe buried in the ground, which we can't see, and we've happened on that before. So next up, very similar to the last method. The only difference is we're using a specialist piece of equipment called a Campos pipe puller. In this case, we run a cable through the existing lead line, and that cable is connected to the poly pipe in the basement. The old lead line is pulled through and coiled on the Campos machine while we pull the poly line through behind it. Once again, once the poly pulls through to the water main and is in position, the connections are done. So finally up is the molding method. In this case, the mold can be launched using a site level from the water main. But in some cases, we've launched this from the basement if the right conditions exist in the basement. You need a lot of room for that to happen. And you also need a large enough opening in the basement wall to allow the mold to pass through. Once set up, the percussion action creates a borehole. The new poly line is pulled through the new hole, and the connections are done. So just to recap, at Crown, we're offering a 360-degree solution for the lead market. We find it and we fix it. So if you have any questions, my details are below, and this presentation will be available afterwards. So back to you, Rich. Thank you.
Thank you, David. That was some great information. All right. We have another question. The following is true about galvanized pipes required GRR replacement. A, cannot be partially replaced. B, requires lead pipe to be aware upstream. C, attracts lead particulates on its surface. D, the major reason why ElectroScan performs a lead swap test to confirm a GRR and lead residue. Or E, is it all the above? It is all the above. Thank you. Mike, take away.
Thanks, Rich. Just want to go over a couple case studies for you all. We're going to discuss the city of Baltimore, city of Rock Hill, town of Medley, Florida, elementary school in California, and Bard College, New York. You're looking at photos that were actually done last week on site. The city of Baltimore had basically they invited a bunch of utilities to come out and see the work in which we do and to explain the process. And as you can see from the pictures going from left to right, we did a 30-day notice to homeowners and a 2-day prior notice. City of Baltimore is using AI data modeling with their consulting engineer, to try to determine how many of their 177,000 unknowns they can figure out. So we obviously then do the service line inspection. You just look at the reporting, we flush the line, and then we do the customer notifications after the fact. As you can see, unfortunately, we left a filter there because we actually found a lead line. But most importantly, though, what you're seeing here is we're working through all 14 districts, council districts of the city of Baltimore. And what we know is we know right then and there. And to quote Paul Sand of last week, he said, hey, while I'm not happy we found a galvanized line, the most important thing is this is now one house that's off of our list, and we can make plans now to go forward about replacement of that house going forward. And that's the critical thing, is taking those unknowns and making them known and doing it in less than an hour per location. Rock Hill, South Carolina was a very early adopter. In fact, the state of South Carolina was the very first state to approve swordfish use back in 2022. In fact, Matt and I will be back in South Carolina with one of our another clients very shortly here. But the biggest thing about Rock Hill is this is a community that has no history of lead. They're in the real problem because they don't have a history, but they have to prove it. But they do have galvanized. So Rock Hill was a partner with the US EPA and the state of South Carolina Department of Health. to research and review not only what they were doing on the AI data modeling, but also on use of swordfish as well. Town of Medley. This is in Miami-Dade County, so southern Florida. One of the unique things here I want to draw your attention to is population. This is a town that's roughly 2 miles by 3 miles. Exceptionally small, typically what we find in Miami-Dade in South Florida, population of 1,036. In the daytime, though, the population of this community is over 60,000. And that's because it's a huge industrial and warehousing area for the whole Miami-Dade, Fort Lauderdale area. It's located about 3 miles away from the Miami International Airport. But the bottom picture is what I want to draw your attention to. Miami-Dade and Medley, they do not have typically single-family homes. What they have are mobile homes and manufactured housing. So because the community we were looking at was a retirement community, lower income, as an area and community of concern, we did the inventory there. We went through about 368 houses on an outside meter box situation, about 3.5 weeks, and they submitted their inventory on October 16th to Florida DEP. There was no lead discovered. This next one, though, is the one everybody should be paying attention to. And here's the reason why. The LCRI talks about tier 2 locations. Those are your hospitals, your elementary schools, your public schools, your senior citizen housing, your anything you want to discuss where your sampling procedures are going up, your notification levels going down. But this is a school that has high lead readings. Where are they coming from? How do we figure it out? They've done everything in their power. They've added phosphates. They've done everything. It's on a well, basically, system. Where's all this coming from? They couldn't figure it out. What you look at in the bottom, what we were contracted to do, is to look at every possible water source coming into the pipe. In the bottom right-hand picture, you see a picture of myself and Matt. We're investigating the 12-inch asbestos concrete pipe that was coming into the school. And the reason we were, for those of us like I do in upstate New York with ACP pipe, when we put it together, we used oakum and lead packs typically. So we're trying to determine, is there lead in the raw water line? Unfortunately, we found 15 sources of lead. Now, I want to make that point very, very clear. I said sources, not lead lines, because we didn't find a single lead line in the facility. What we did find were numerous areas of old brass fittings that tested positive for high content of lead. It's just a fact. So this is a case of where during all of that happening, we were able to notify that and start removing those valves out of the system to make it better for the kids. Lastly, Bard College. Now, this is a college in upstate New York. It's actually a rather well-known one in the Hudson Valley as well. 650-acre campus, massive campus. Probably over 150 separate historical buildings on site. They got nothing. They got a master meter out front. They had no data of anything behind it. What are we supposed to do? We went through basically 100 buildings originally. We worked way down to about 47 buildings. The biggest thing I want to draw your attention to is on the picture on the left-hand side. When we're potholing or excavating, we're taking a look at 18 inches or 2 feet of pipe. That survey was 50 feet. Now, we can't always get 50 feet. Sometimes we only can, as Matt said, we only can get 3 inches, or we barely can get into a line because the galvanized pipe is so corrodedly shut. But where we can go, we can get. So we can get out to the curb stops. We can get out past onto the public and private side, because again, this is in upstate New York, so all of our meters are in basements, so we're always going against pressure back out to the street. So with that, back to you, Rich.
Man, thanks, Mike. That's some great information. Now, this is going to be the last question. It's a true or false question. Predictive models can easily tell if multiple pipe materials are present. Predictive models can easily tell if multiple pipe materials are present, and that is false. Predictive models are best to provide neighborhood level assessment, but have a poor track record predicting utilities side and private pipe material. Wow. All right, well, thank you. We're going to wrap it up. Now, we're going to wrap it up, and I'm going to do some Q&As. But before I let you go, let's remind you that our goal is 100% removal of lead pipe. 100% removal. And that also means 0% removal of copper pipe. That is our goal, 100%. Okay? All right, we're going to get to the Q&A. And there was a question in the Q&A. And the question was, what is the smallest diameter pipe the swordfish probe can go into? And Matt, take it away.
Thanks, Rich. Yeah, we actually had a handful of questions in the chat during the presentation. I'll go over a couple of those because I'm sure it's questions that other people had that maybe just didn't ask. So to answer the question that Rich just read, the smallest diameter that we can enter is a 1/2-inch line. So the system's designed to do inspections from 1/2-inch up to a 3-inch pipe. So some of the questions we actually had is potholing considered a major or minor disturbance? And I wasn't 100% on that. Mike, do you know? Is that major or minor?
So the major and minor question was originally from the LCR, and that has now been removed to point everything as a disruption now in the LCRI. So in fact, in the LCRI, they specifically call out excavation and hydro excavation are specifically now a disruption. So as a disruption, like I said, the way the LCRI is written, simply turning off the valve of a lead service line or a suspected one is considered a disruption. So that major minor is from the old rules, and now the new rules, everybody is. So
thanks, Mike. Another question we had is there any geographical regions which tend to have more lead and copper piping than others? And, you know, I answered this in the chat. I wasn't 100% sure because a lot of people just have a lot of unknowns. You know, we're doing inspections all throughout the US and we seem to be finding lead everywhere. But I don't think there's certain, I mean, I'm sure there is that maybe is more popular, maybe certain cities installed it more than others. But I don't think there's at this point, we know of a certain geographical area that is just known for lead.
I haven't heard of it, and I will tell you, you know, one of the concerns here in California is just looking by the date of construction. A lot of folks here in Sacramento don't realize Sacramento has more homes constructed in before the 1930s and 40s than Flint, Michigan. So you want to be able to go ahead and do the testing of the water pipe itself, because plumbers introduced, you know, lead pipes all at different times. So what we're finding across the board, it's not geographically based, it's time based. And it's looking at the low hanging fruit really being, you know, those homes that were built before 1939, 1940s, 1800s. So those are the ones you want to look at.
Yep, exactly. Another question we have was, what's the flushing process look like? And I'm getting a lot of questions about the flushing and the disturbance. You know, what happens? We put our you know, quote unquote auger tool inside the line. If you guys see the probe, it's not necessarily an auger. It's just a push. We're not, you know, a lot of people see the swordfish and it's built off of Milwaukee drain snakes. So they instantly think that we are boring into this line and ripping and tearing, and we're not. It's actually unlike a drain snake, it doesn't automatically feed out or anything like that. It's all a human push, so you have, you know, you can feel how much resistance you have. So we've never broken a pipe or anything like that from pushing this inside a line. And yeah, things do come dislodged. Obviously, galvanized pipes, there's lots of debris in those, and we follow the AWWA flushing process. So if we're in a meter pit and we pull the meter out and we did an inspection from the meter to the main. We'll leave the meter out so we don't flush any debris into the meter, and we'll flush that pipe. And once we're done with the flushing, we'll reinstall the meter. Now, if we've done an inspection from the meter to the home, we'll install the meter and we'll flush out of the hose bib. So we don't go up into the house and flush. We flush out of the hose bib. And this has been tested, like I've mentioned in the chat. San Antonio Water saw us. They wanted to see, is your flushing process going to clear out enough debris? And what we did is they didn't even want us to flush. First, they said, do your inspection, and we're going to sample. They took 8 samples right after we did the inspection without us flushing, and they wanted to see how fast the debris cleared out of the pipe. And I think it was by the 4th or 5th sample, the water is back to the same level that we were at before. So exactly. It was like almost instantly. It wasn't, the first few seconds of the flush, there's a lot of stuff that will come out, especially on galvanized pipe. But, we flushed this thing for 30 minutes. By the time it's done, we haven't had any issues. No one's ever had discoloring in their water. We've had independent companies sample the water. Some people ask, do you guys sample after each test and give that to the homeowner or anything like that? And we don't sample after each test, but we have had utilities want to see, is our flushing process sufficient for what we're doing, and is the water going to be safe to drink after we do our inspection? And the answer is yes, it is.
Yep. Matt, I'll just make a comment. I was at the EPA October of last year, and actually brought videos and showed them what the disturbance was after potholing, and also what the disturbance that is created just from turning on and off the water meter, just re-energizing that water service line, the water hammer that is created. And again, you have to be in the industry to know these things. A lot of the folks, I don't want to say they don't get out of the house very often, but a lot of the folks had never seen, and we showed a video of a plastic tube, but when you re-energize, just turning back on that water meter, re-energizing that line, they had no idea of the force that in that process will just shoot out and clean up, the sides of the wall. So I'm not going to say I was responsible, but we may have contributed to the addition of better understanding of disturbances just from turning on and off the water meter, and also disturbances here. So, we just didn't want to be, singled out for this, when we've been putting also TV cameras in pipes for years as well. So it really has become a non-issue as far as disturbance. You just have to follow the AWWA standards, and you're fine with that. It's just that now every other activity is going to be included in with that. So we're happy that light bulb went off.
Yeah, so that's a good question, and I understand the concern, with debris and stuff in the pipe. They don't want angry homeowners after we do this inspection. And so far, so good. We haven't had any complaints. Another question is, so the process of checking the line with this takes approximately an hour per location. Is this for both the customer and system side? Per location, we're typically about 30 to 45 minutes. Obviously, some things we have to take into consideration. We've done inspections in 15 minutes. It just depends on how much we run into. How easy is it to remove a meter? Are they hard to get to? Do they have real small openings on the meter pit? Are we in a basement that we get there and it's like, oh, there's a bunch of stuff in the way, so we have to ask the homeowner, hey, can you move this bookshelf away from it? So that kind of stuff will slow you down, of course. Sometimes a valve is bad and we have to wait for the plumber to come remove it. So those things will slow you down, but we're typically 30 to 45 minutes per location. So if we go to a house, about 30 to 45 minutes.
Hey, Matt.
Yes.
What's the most homes you've done in a day?
The most we've done in a day, these were meter pit inspections, but the most inspections we did in a day was 26. So okay. We get a lot done, but that's best case scenario. We were just really in a good groove. The housings were close. We didn't have to go too far across town for each individual house. So yeah, we could get quite a bit done in a day.
And in all fairness, I mean, where we go into, the clients in New York that we have, going into a basement, or no one's at home, even though we may have scheduled it, there could be, or moving around things. I mean, you get 5 done in a day. That may be all you can get based on what you have. So it just varies. It'll vary city to city. So, but good size range.
Yeah, another question we had, and this is actually a good one. I don't think any of us have talked about it, and this is something that's definitely used in our day-to-day when we're doing inspections. But it says, why are there photos of lead swabs throughout the presentation? Why would you need those? That's actually a really good question. So what we do with those lead swabs is, if we run this down a pipe and we're having a reading of lead or galvanized pipe, we will take it out and we'll actually swab our probe. This does 2 things for us. It kind of is like belt and suspenders to hold your pants up. If the computer says there's a lead pipe, then we swab our probe and there's lead on our probe, then we know we have a lead pipe. The lead only came from one place. Now, of course, there's a disinfectant process. We change the probe out, all that kind of stuff once it has lead on it, because it's, believe it or not, you can't just wipe it off the rag. You have to use a chemical to remove the lead. So it's a little bit of a process. But also, if we run into a galvanized pipe, now you guys all know there's galvanized required replacement. If we push into a galvanized pipe and we take it out and we swab it and test positive for lead, that galvanized pipe has been downstream of a lead line and now is contaminated with lead. Now, if it tests negative for lead, we at least know that one's not contaminated with lead. Now, as far as lead being downstream somewhere, it's obviously not contaminating that galvanized pipe. So that's just something to help the utility with. Now, if it's testing positive for lead, obviously we know there's lead. We also will use these swabs on copper pipes. Old copper, we'll want to see, is that lead solder on there, and that's just something we can put into the data as well. So those swabs are pretty handy when you're out in the field.
Yeah, we're taking readings in sub-seconds. So, when we're actually going through a copper and we're seeing that blip, that change in resistivity, that change in material, that's exactly what we're looking for with those sorts of indications. Well, we're coming up on the 9 o'clock hour. I'm going to stop you right there, Matt, and thank you so much for that. I'm going to leave this slide up for a few seconds, maybe the next minute, because we want you to download this presentation in its original format. This is a link. Use your camera. You can see where the link is. It's a Microsoft PowerPoint.pptx file. Tear this thing apart. Use what's appropriate for your system. It's about 381 megabytes. This link will be available through the end of the month. We have so many new things going on, so many new case studies, so much more information. We're very busy, especially with our partners and all of our sponsors here as well. So I really just want to, from this point on, and again, if you miss this, if you don't have a link, please email us. We'll give you an email in just a second. I want to thank all our speakers, Mike App and Matt. Thanks so much for the Q&A. Rich Brown, and also our good friend David Kinsella from Crown Element 82 PE Pipelines. Boy, it's a big thing. And again, if you do have any questions, please email Rich Brown, electroscan.com. Text him. He gets lonely during the night. Or just go to our website and you can use that as well. Again, we run a full circle shop from inspection to now testing and replacement. So with that, I'm going to say thank you for coming. We want to help you turn those unknowns into knowns. And with that, I'm going to say that's all, folks. Take care and have a great day. Thank you for attending.